For any car, the speed in a corner is the square root of the grip times the corner radius. Why is that? And how can we use it? Welcome to Dig Deep. Today's video is about racing lines and corner radius. Why it's so important to maximize the corner radius. That means using the whole track, reaching the apex in the corner in the right point or the right spot. So actually you can do the corner as wide as possible. A wide corner means you're going to have a higher minimum speed. Today we're just going to cover the basics. Of course, it depends if you have a series of corners. It depends if you have a long straight before the corner or after the corner. But today I'm going to explain why there is only two things that can influence your minimum speed in a corner, which is grip, setup, downforce, new tires, etc., etc. If it's raining, it's less grip, and corner radius. The wider the radius, the faster you can go. So it all starts with Newtonian mechanics and the equation that centrifugal acceleration equals v squared divided by radius. But before we go into complex math, let me show you two examples of simple corners and see the impact of this equation into those corners. So for this example, we're going to use a car that is able to pull 2g of lateral acceleration. That means 20 meters per second squared, which is quite a lot more than a road car. Let's say a sports car in the road can maybe pull 1.2, 1.3 g, which is the acceleration of gravity, right? We're just transforming g into meters per second to fit the equation. And a Formula 1 car can pull sometimes 4.5 g in a corner. We're going to use 2g in this example as our base to calculate and to see just the corner radius and how it influences the speed. So in this example, we have one hairpin, 180-degree hairpin, that it has three different radius in this case, right? And we know that the car is pulling 2g of acceleration. And in this example, green and red, they are the same radius. Red misses the breaking point, for example, and misses the apex. But in this case, 180-degree will have the same radius as the optimum, which is green. And therefore, they will have the same speed of 148 kilometers per hour. But the difference between the red and the green will be just the distance. So 2 times this yellow part here that we can see on the side, one on the braking side and one on the acceleration. So red will have the same minimum speed, but will cover more distance, therefore going slower. But what happens if you leave some margin here on the entrance and on the exit? So your radius goes down to 78 kilometers per hour. So basically, to pull the same 2g as the green racing line, the blue will only achieve 142 kph, leaving 6 kilometers per hour on the table and a lot of lap time. And that's why it's important to use the whole track to maximize the track for this specific corner. But we'll see that reaching the apex, reaching the point here, it's very, very important, especially when it's a 90-degree corner, like the next example. Now in a 90-degree corner, there is a huge difference between hitting and not hitting the apex, as we can see now. So you can see that in this 90-degree corner, you have the same 2g acceleration, but there is a big difference in radius between the optimum green and the red. In this case, red misses the apex by this arbitrary distance that I chose, and by doing so, the radius goes from 190 meters to 120 meters. There's a difference of 70 meters of radius in this case, in this 90-degree corner. And to achieve the same 2G, the 20 meters per second, the speed difference between the red radius and the green radius is 44 kilometers per hour. So if a driver misses the apex in a 90-degree corner like this, it loses almost unimaginable speeds, because 44 kph is huge. And therefore, by maximizing the radius, sometimes using the curb here, sometimes using the curb on the exit, sometimes using even a little bit on the entry, but maximizing the radius in a 90-degree corner yields a much, much faster lap time. That does not mean that you shouldn't do it in 180 degrees. But my point is, by exploiting even more track limits and the edges of the track in a 90-degree corner like this, or closer to 90 degree, yields much higher difference in minimum speeds. And therefore, also we're going to talk about this in another video, which is in this corner specifically, the incentive for a racing driver to go over the limits is much bigger because of the yields of the lap time. And therefore, designing a track which has more corners that allow you to increase the radius and gain a lot of lap time will influence the drivers to go over the track limits, creating the problem that we speak so much about it. So I hope you enjoyed this video. And please don't forget to subscribe and share and leave your comments on how to make them better. Thank you very much and see you next time.